this is Richard C. I'm a math tutor here at Wyzant, answering questions submitted by a student. It looks like the student is taking Algebra 2. So let's take a look at these. These are really just combinations of two functions. In this particular case, each function is a polynomial, so that gives us some shortcuts that we can use here. Okay, just trying to get this to settle down a little bit. All right, so we have two functions, f of x, which is x cubed plus 4x squared. G of x is 5x squared minus 2. They want to know what f plus g is. So this is supposed to be written, it would be f plus g of x, like that. And this is just f of x plus g of x. And so we would just add these two together. So it's going to be x cubed plus, it's 4x squared and 5x squared is 9x squared minus 2. The domain is going to be all real numbers. So if the teacher wants it in interval notation, it would be that. Sometimes they'll accept this abbreviation, all real numbers. So capital R with like an extra vertical in there. It's nice because we know that this is a polynomial, that's a polynomial, and the sum is a polynomial. You can see that. And all polynomials have a domain, unrestricted domain, all real numbers. So f minus x, this is supposed to be written as like that, and that's just going to be f of x minus g of x. So that's going to be x cubed, and then we have a 4x squared minus 5x squared, so negative x squared plus 2. And so this is also a polynomial, so it has an unrestricted domain. All real numbers. FG is not supposed to be written like that. It's supposed to look like f with a closed dot g of x, like that. That's the proper way to write it. And you could write it also as f of x times g of x. And this just gets a little bit tricky. Cube plus 4x squared, not particularly tricky, not particularly difficult. Just going to multiply these two polynomials. Okay, so I'll distribute the x cubed first. This is going to be 5x to the 5th minus 2x cubed. And I'll distribute the 4x squared, so it's going to give me 20. X to the 4th plus minus 8 x squared. So yeah, so 5 and a 3 and then a 4 and a 2. Yep, that's great. And because it's a polynomial, we know that the domain is unrestricted. The only difficult one, somewhat difficult one, really is the division. And this is supposed to be written f over g of x, like this, with a nice bracket around it. And this is just f of x over g of x, and this does require a little bit of thought here. So it's going to be x cubed plus 4x squared over 5x squared minus 2. So this is called a rational expression, and usually what you want to do is factor it just to see if there's anything funky going on here. And I don't see anything. So the only thing that we have to watch out for here is we can't allow the denominator to be 0, because anything divided by 0 is undefined. So we have to go out and just solve this. 5x squared minus 2 can't be 0, which means that 5x squared can't be 2. And that means that x squared cannot be 2 over 5. And then that means x itself cannot be plus or minus square root of 2 over 5. And most teachers will say you shouldn't leave it like that. You should rationalize the denominator. So you multiply the top and the bottom by the square root of 5. So it's going to give you 2 root 5 over 5. So let me just show you the step here in case you had some trouble with that. So the square root of 2 over 5 is the same thing as the square root of 2 over the square root of 5. And then you just multiply that by square root of 5 over the square root of 5 to give you the result. So, oh, I'm glad I did this the long way. That was a mistake, wasn't it? Square root of 10 here. So square root of 10 over 5. There we go. Oh, I'm glad I caught that. Okay, so now, so that's f over g. So right, so our answer here is this. This is f over g right here. And for the domain, sometimes the teachers will let you get away with a little shorthand here. You would just say x is not equal to plus or minus square root of 10 over 5. But if the teacher insists on interval notation, we would just go from negative infinity to negative root 10 over 5. Union negative 10 over 5, root 10 over 5 to positive root 10 over 5. Union positive 10 over square root of 10 over 5 to infinity. These are round brackets throughout. Let's fix that. Because we intend to exclude negative 10 over 5 and positive 10 over 5, root 10 over 5, negative root 10 over 5, and positive root 10 over 5 are excluded. And that's why we're using round brackets here to exclude the endpoints. So negative infinity is excluded, negative root 10 over 5 is excluded, negative 10 over 5 is excluded again, and so on. Okay, so I think that does it for this question. It's really not too bad. You're working your way up to composite functions, which is really a more complicated topic, and perhaps you'll want to send another problem in to us when you reach that topic, which should be any day now. Okay, well, I hope this explanation was helpful to you, and I'll see you again sometime. Bye-bye.